Good. So we made some progress last time in our pre-processing of fMRI data, because we, from just specifying an overall structure as we did in the first session, we now actually did something in the last session. So we worked on the direct to NIfTI conversion, or the data import, and then split up this 4D file to many 3D files, because SPM still wants to work like that. And then we wanted to do spatial realignment, and we stopped actually at data specification, so where we actually have to select which data files we want to realign. And the reason why we stopped was essentially that I was hungry and couldn't be bothered to figure out the code. So, which is usually when I stop working, or Horst is saying he's hungry, and I also stop because I cannot concentrate anymore. And he's like, wow, 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 wow. Anyway, so this is the code that we dealt with. So I then in the afternoon I corrected things. So let me talk you through it. So the whole thing works with this SPM select function, which is just like the dir function. And for that, one needs to specify a directory in which one wants to look what kind of files there are. So that's here our run directory, because we're doing this loop over runs. Maybe we should also comment that, iterate over runs. And then we have a run directory, and then the question is, what is the filter that we specify for SPM select? And this is always a little bit annoying, because one can use wildcards and this kind of, I think it's called regular expression stuff in MATLAB. And there one tries to be as specific as possible, but not too specific, so that still many files can be found. And what this whole thing will come down to is that for subsequent steps, there will be stubs or prefixes on these files, and if they are raw, there's nothing. So this says basically look up all files that start with a CB underscore, and in the end have something like 0100, and then any number, and again are of NIfTI type. So this makes sure that we only get the files we're interested in and not the other one. So this one we don't want. That was our 4D file, and we're looking for those that have like this 100. And these are all our NIfTI files of interest until 444. And then actually I just ran the code up to here. Then we have, oops, that doesn't look good. Then nothing worked. Why didn't it work? It worked at home, but it's still not working. That's not good. Let's check what's going on there. So we might have to work further. So I actually, at home it worked, but that might be still a directory issue. So let's have a look. Did any of you get this to work actually at home? No, you didn't. Try. Good. So let's have a look. Like I said, this is the kind of the hardest thing in the whole thing, is to specify where which kind of data one wants to use. The other stuff is really, really simple. Now we're running the thing again, and wait a little bit. This is maybe due to the fact that somehow the stuff is wrong, or I'm actually in there. Let's see what we have. No, it worked. So it definitely has found the files. So F is now the list of files. This might be that it was in a for a second run or so, now only ran the upper thing. I think for the first run that might have been the reason why it didn't find them. So now the specification of the filter and finding the API findings works, and then the last step in this is to render these files as a list that SPM likes. So this is what this nice code here does. Essentially, this just puts a (1) behind all of them, and the whole thing then looks like this. So it puts the full path to it and a (1). For some reason, there needs to be this (1), and then in principle the realignment could work, but because maybe let's do it like this, so that if we now run things again, we only always run it for one run. Then we can go over all runs. So I will do it once more with everything, and then I will comment out the stuff so that we don't have to run it all the time. But in principle, now the realignment should be possible to run. So remember that one thing was specifying the data that's happening in terms of the file names, and the other thing are these options for estimation and resampling, as we discussed last time. So let's see whether that now works. Of course, you can also test this. I also recommend that if you test that, don't use the entire data. Start testing with like 10 files or so, especially if you do realignment and so on, because otherwise you always wait for a long time until there's maybe, in this case, if you have 5 runs, are 441 volumes, until it's finished over all these 2,500 roughly files and so on. So start with 10 files and remove the rest or something, so that you don't wait but program all the time. However, here I'm just focusing on one run now, and it should work, and then we'll comment it out. So let's see whether we crash. No, we don't crash. So now it's running the realignment. And it's first estimating the parameters, which I think it is still doing. And once it has finished estimating the parameters, it will reslice or interpolate the volumes so that the new volumes are then realigned. We will look at these images not all of them. There's actually, I think there's some on the SPM website. You also find plugins for SPM, and I think there's also a plugin with allows you to create movies from images. So of course you can also write that yourself, but you can also use this plugin, and then you can create a movie over the time series and hopefully see something that when it was not realigned, that you sometimes see these little movements, and after realignment, hopefully that it looks better. We will just create images of static images later on to just have a basic sanity check that things worked. So now it's reslicing, and what you see is so it's creating a lot of new volumes, and they have this new prefix R, which is the realignment file or realigned file, and as I said, these intermediate files we will also delete at a later time point, but currently it's writing them. So it's quite old school, I find, these days. I mean, it would be, it could be done in one file without these many files and so on. So there is room for improvement of SPM, not only in terms of the mathematical algorithms of everything, but also in terms of how the data is organized and stored. Because with this writing to disk that many times, that's really not that efficient, and I would assume that in the age of big data there exist much more efficient ways to handle this. Good, so now the realignment is done, and we can actually start a new thing. So let's make sure that we don't delete things now always, and that we don't import data again and again, and that we don't realign data again and again. So I'm just commenting everything out. You can also do that with a if statement if you want, but I'm not doing this right now. And now the next thing would be spatial normalization, so standardization to the EPI template. And now we have seen many times how this works. We can go a little bit faster, because otherwise I will fall asleep. And basically do what is actually more real life. So you have a script that somebody else used, and now we could of course again go through the GUI and create this and then copy it, but we already have somebody already did that for us. So let's see whether we can reuse this. And also see whether we can improve what we have done. So now you know how we created via the GUI, we created this code. Now I'm copying this kind of code from somewhere else. And let's see what it tells us. So first there's something about the tissue probability MNI template image. So we're using this new normalization of SPM. So in the old days, so you know, with normalization you can do many things. So you can normalize the anatomical, so the T1 image to the T1 MNI template, and then use these parameters and apply them to the EPI time series for normalization. And some people think that's better. And you can also, or in the old days, I directly normalize the EPI images that we acquired to the EPI MNI template, and then there's this new normalization that was introduced like in 2014, 15 or something, which doesn't use the MNI template per se, but it uses the tissue probability maps, because it uses some what's it called? Co-registration of tissues to check for the normalization. This uses this tissue probability maps, which also encodes the MNI template. So for normalization, what you need to specify is kind of a template to which the data is normalized, and this is here specified as the MNI template image. Do you rather want me to do this via the GUI, or is that fine? It doesn't matter. Good. So we do it this way. So you can, of course, also do it via the GUI if you want. And then now we copied this from other code. Of course, this code is not written for what we have in mind. So we need to specify where this is. And this is in the SPM distribution. And in our case, it's the directory is actually this one, which get rid of this one. Which is not Padia. We have another file here. Padia s.dir. Padia. Now we can pwd. So our SPM distribution is in our working directory, so we should be fine with the print working directory, and then specifying the correct SPM folder. So that would be print working directory, and then it's in the tissue probability maps folder, which is here, and we have this, and there's this. Let's have a look at it. So what we actually, what we're actually looking at, what we're using as our template. This double SPM structure is also a little bit annoying, but whatever. Might actually do check rec. So this allows us to put up multiple images. So we take this tissue probability map, and we might actually take some of our data. So some of the realigned ones. Let's see what we get. So this is the tissue probability map, and as you can see, of course our API only, as you see, scan parts of the brain, but you also see that this is clearly not aligned. So if you go, for example, to the back here at the template, you see that we are here really far away from visual cortex and anything. So this is clearly not aligned with this, and it might also, it's not that easy to see that it's also not, it's actually, I have a good, that's my brain, I have a good MNI brain, so it's almost of the size of the MNI template, but clearly it does not match. And if we want to now overlay data from multiple subjects, then we need to make sure that it's all in the same anatomical space. So we need to align all of our data with this template here. Yeah, and this is what the normalization does. It not only aligns it, but it also, of course, blows it up or shrinks it to that, but that doesn't seem to be the major issue here. Good, so that's the template. And then we are not quite done yet. We have to specify where that is. Sorry. So this we get from print working directory, and this is our double SPM folder structure, and then it's in the TPM folder, and it's called TPM Nifty. So in principle it should find that, and then we have to again now decide which images we want to normalize, and of course we can just build upon what we've done up here. So we can reuse that code and get rid of this. So we are still working in the same run directory. We of course want the realigned data now, so we're using an R because we want to normalize the realigned data, and the rest should be as previously. And maybe let's first see whether this actually works. Should be safe to run this, I think. I hope. This is from copying the code. So we made it better than in the old script because we defined a structure, and that was there. So now that we figured out the code last time, we can easily reuse it, and it's still working. So these are now the realigned files, and we can then proceed. So what do we have here? So we are again initializing a job file, and then again we have to specify what we actually want to do. So as you can see from the comments that were in the old script, we first specify what we want to normalize, and because the EPI data are all realigned, they are all in alignment with each other. So we only need to estimate the parameters for normalization for one of those, and we're taking the first realigned image from the first run, which is in this cell array fs. And then we decide that we want to now normalize all images, not only one. And then there are, of course, again, estimation options, some form of regularization parameter, which you can always understand as putting in some prior, and some smoothing again in terms for this estimation, and then the specification of the tissue probability map that we want to use, and the MNI normalization that we also need to carry out. So this is already an MNI space, but we specified that we also want an MNI. You can also leave it in, I think, in native space, then it would re-interpolate it to the native space after using this tissue probability map. So there is a paper on this neurosegmentation. So this is again John Ashburner's work. If you want to know some of the details of how that works, of course not all the details are in there. Some more regularization parameters. Some more parameters. Which are the default parameters. We didn't change anything. Still estimation. More estimation options. One thing that is somewhat interesting, which you also specify in terms of the here. It's not nice, it needs to be there. There's an reinterpolation step in the normalization. So you acquire the data in some kind of native space. For example, in this case, I think it was 2.5 times 3 times whatever voxels. And at the normalization, you can choose whether you want to reinterpolate the data. And often this is then reinterpolated to 2 by 2 by 2 voxels. Doesn't need to be done, but is often done. And this is specified during the normalization step. Also, what these numbers are, so this here, these are the MNI coordinates. So I guess you've all seen MNI coordinates in papers. They are in millimeter, but of course minus 36, 0 and whatever in MNI coordinates means something in the MNI template space. So for example 0, 0, 0 is at the anterior commissure, and this is the bounding box around the MNI template and specifies the X, so minus I think it's left to right, to 78, the Y and the Z coordinates. Then some interpolation constant, and then an N prefix for normalization. So, and here we also save the job file. We didn't save the other one. Let's not do it. It's in the script anyway. But we might also put information in there. Although I don't think that subdirectory actually is something we knew before, so let's rather delete it. Of course, you can do it if you want. And then let's try to execute this one. So it's running, so it has found some data. Yeah, it's now using this tissue probability map to segment this first image because it wants to realign this to the, not realign, but align and morph it to the MNI template. And that's what it's doing. Questions right now? Because right now we're waiting. So again, the details. So this is, there is a mathematical and statistical framework behind also all of this pre-processing. So as I said last time, we could have the same thing we have about random field theory-based p-values. We could have a similar course about this normalization here. But then I decided not to emphasize pre-processing so much, but rather statistical modeling, because after all, the cognitive stuff and the things about how the brain works comes in at that level, and not at whether you filter the data a little bit like this or a little bit like that. Although it, of course, influences your final results without question. So that was everything I prepared for the waiting period. So we have to now be silent until the thing is done.
There are also there's an increasing number of pre-processing standard routines, right, from and all these people. Would you recommend using that, or
it's like a planted question because we discussed that previously?
I mean, not the Pi thing, but in SPM.
Yeah, I mean, whatever. So, how much more? What else do you want to standardize than using the SPM defaults?
So in that sense, it's already standard.
Yeah, this is so far from doing any actual cognitive and research work. This is just basically turning on the machine to do doing some image pre-processing. I mean, it's not that first of all I or you know exactly what's going on, or that we really care, or that we want to actually, because there are different parameters, of course, in these things, that we want to play around with them. Of course, you can play around with these parameters, like the realization parameters and everything, for the rest of your PhD life, and then have a little bit pre-processing this, pre-processing that. But so in principle, I think this is already fairly standardized if you use defaults, and if you then again have a standardized pre-processing thing, I'm not quite sure what that means. So I rather would recommend people instead of writing pre-processing toolboxes or classification toolboxes, or what was the latest toolbox that I got? That was last Friday. There's a deconvolution for EG toolbox. Instead of people writing toolboxes and putting up fancy websites to sell their toolboxes, people should start thinking and not writing so much code, but write more theory and not write toolboxes. Nobody needs any more toolboxes. There are enough toolboxes. There are enough toolboxes to do these things really simple as we do here, and any more toolboxes just are a waste. I think. It's a waste in terms of the time that people spend writing toolboxes, and it's people using toolboxes. Like here, of course, it's nice that we can use the toolbox, but we don't know what's going on really, and what does it all help then? So good, we're done with the normalization and filled this break. So maybe let's have a look whether that worked roughly. So I guess we can actually in the second, let's migrate remove SPM from the path command. We can actually start the GLM also today. Let's first have a look. So let's have a look at a realigned one, a normalized one, and our SPM template. Can also actually use here in the single subject. Maybe the one better, the on MNI. So, look good. It doesn't. It's fairly at the. That actually is quite bad. It's fairly low. Have a look at the other one. Jesus, what am I doing? Am I doing the right thing? What am I doing? We have one here, so I'm doing the right thing. Interesting. So that doesn't look too bad. Wonder why it looks so weird with a single subject. So as you can see, this is the template, and this is the realigned one, and you see that it somehow has been morphed, and it's not the greatest thing ever, but you see that the cerebellum here and this, I think it's called the tectum of the cerebellum, so this where there's this meninges going in here, so there's dura mater between the cerebellum and the visual cortex, that matches okay-ish, and the end here of the brain also matches okay-ish. I mean, it's definitely not the easiest normalization thing, because we only scanned kind of a third of the brain, but it doesn't look too bad, so that looks good. So somehow the single subject T1 and the stitch probability map, why doesn't that look that good? Well, that looks aligned. That should look aligned. That's one. I'm a little bit confused. Maybe I looked at the wrong image there. Jesus, no, I used the wrong tool. That looks better. I must have looked at something at another realigned image when I first looked at that, because now you again see that in terms of the visual cortex and this border between the cerebellum and the cerebellum here in the EPI, that looks roughly aligned. Of course, it looks a little bit weird now because it's a little bit stretched and stuff, but that's what happens when you normalize stuff. So maybe I think I looked at the wrong image, which then of course also makes sense. But you also saw it in the beginning, it didn't look realigned, right? Or you didn't realize anything, you're just staring in the air. Or it didn't look normalized, sorry, not realigned, normalized. So maybe I just looked at the wrong image. No, let's stop this because otherwise I'll just confuse you more. So this is the normalized one. This is the T1 in M&I space. We also looked at the tissue probability map, which is also in M&I space, and we see that it's from what one can see. I mean, it's of course hard to see any fine structure in the EPI images, but in terms of the back of the brain, that roughly or clearly matches the M&I template, and in terms of the this strong anatomical feature here between the cerebellum and the visual cortex that matches. And since we are only interested in visual cortex for this anyway, because we're dealing with visual data, it's also fine. Maybe let's have a look at the ventricles, which is a little bit hard for my ventricles because I have this very large left ventricle, but you see that also the ventricles are roughly aligned. Yeah, so I think there might also be an option to overlay. I think there is an option to overlay things in SPM as well. In Brain Voyager, there's also a lot of functionality overlay stuff, but this is kind of a straightforward thing to check whether actually the normalization has worked, and I declare it has worked. Any objections?
No.
Good. No, because it's kind of maps it. Of course, this one can also use the batch editor to write a script that does not the check itself, but at least bring up the images. So you know there's check rec, and then you can also make a script that in the end, I'm not sure when I want to do it, brings up these images and you can put them together. Maybe we do that after all. Let's first finish the pre-processing in terms of the last step, which is smoothing, and this is really trivial. So smoothing. So we don't do realignment. And then we again use our code we have for looking up the data. We need to make sure that we use our S1 tier here. And then this, look briefly at the parameters. So for smoothing there are a few parameters. The essential one is the smoothing kernel in full width half maxima, which you might remember from the other course if you attend this course. And we use a prefix of S, and we here use the normalized and realigned ones. And let's see whether we find the data. Yes, we do. And then we can just smooth the data to make it look more smooth. Oops, wrong script. Then we're done with the pre-processing. So maybe in the beginning of the next hour, we look a little bit, or actually you can decide, would you rather at the beginning of the next hour do a little bit of cleanup of this pre-processing and write a script that creates these images and maybe plot the motion parameters, or would you rather start with the GLM? So who would do some more fine-grained pre-processing, and who would start with the GLM? And the rest? There's a little bit of a majority for the GLM. So now it's doing the smoothing. Now these are of course also good exercise to write a script that does check rec for selected images. Of course you cannot bring up all images. I mean you could, but then you have really many. But for example, looking at the last image and getting the feeling that you did something correct. Good, then let's have a break now while it's still smoothing. And we'll continue at 11.